Welcome everyone to section 4. In our previous section, we walked through the NumPy and Panda data science libraries, so we could access, parse, and combine the data to get some descriptive statistics. We assumed in the previous examples that our data was clean and ready to use straight out of the box. Unfortunately, this is not always going to be the case in the real world. In this section, we'll first discuss the dimensions of data quality, then ways to filter and clean our data, and then we'll also look at outlier detection and ways to transform our data to get some more meaningful information. The quality of our dataset is going to be vital and is in fact one of the largest time-consuming aspects of the data analytics process. If we don't have reliable data, we won't be able to identify causal relationships, make informed decisions, or even worse, just make wrong conclusions based on faulty or misleading data. In order to determine the quality of our data, we'll need to consider several dimensions of data quality, such as the validity, accuracy, completeness, consistency, uniformity, uniqueness, and the timeliness of our data. Validity is really asking, does the data conform to some definition, such as, is it in the right format or range? The accuracy is how well the data is correctly recorded that relates to the real world. Completeness is basically asking, do we have all the data that we need? While consistency is asking whether there's any differences of two or more representations based on the same definition. Uniformity is asking things such as, are we using consistent types of metrics or conversions? Uniqueness is asking whether we have one or more of the same records. Sometimes it might be important that each record is unique and cannot be duplicated. And last, we also have timeliness. Is the time that the data was recorded relevant to our current analysis? All right, now that we have listed some of the key definitions, let's take a look at our sales database and see if we might be able to identify some issues present. All right, now that I have the notebook set up, I'm going to write a small method that's going to take the spreadsheet name and it's going to automatically extract our data frames from it. So I'm going to call this method getDataFrame or just getDF. So what this method is going to do is we're going to give it the file name and the location of the spreadsheet so that it can extract all the data that we need and return a data frame. Now I'm also pulling out the first row as our head just so that we maintain the column names. So why don't we go ahead and see our raw data from our employees data frame. Alright, so let's take a look at some of the employee IDs. As we can see, employee ID number 100112 appears 3 times, when there should only be one unique record for each employee. If we take a closer look, we can see that Adam West has a duplicate record, which might have been developed since one of the records has his middle initial, while the other does not. If we move on to record 14, we see that there's a missing department that the employee Kim works under. In record 16, we can also see that when we pull up the results, the employee ID is not valid. It does not fit the format of number ranges between 10001 and hypothetically 199999. Instead, it has a long string of numbers and letters which don't seem to conform to the rest of our dataset. We also know that James' last name, Teller, is all capitalized, which is not consistent with the way that we store the rest of the last names stored in our database. Last, note from the city it should be San Jose, and omit the state abbreviations. Our last record also shows some unusual inputs. The first name has a capital N towards the end, and an underscore that doesn't seem like it should belong. The first letter of the last name should also be capitalized. Now let's go ahead and pull up the customer's dataset. So I immediately noticed that in record 12, the last name column is missing. But if we check the first column name, it contains 2 names. In addition, the city is listed as Oaktown, which the customer has listed as a nickname for Oakland. But this is not really consistent with our internal naming convention. Looking further into the dataset, we also see the record IDs jump out between 20014 and 20018. So we might want to check to see if there's any missing records or why the jump occurred in the first place. Again, in the last record, we also see some unusual naming conventions for San Francisco as listed as Frisco. Now let's pull up the products dataset. Once again, we also notice some quality issues with the data. Notice the product ID listed as 40013. It lists the price in character format, but instead we should be having the prices listed in numerical. Record 14 seems to be storing a lot of non-valid data for the product and supplier IDs, while at the same time omitting the supplier name. Again, take a look at our last record. Now, it might not seem immediately obvious, but after closer inspection, we notice the supplier ID is not accurate for the supplier name Ropa. Also notice that the cost of the shirt seems suspect, $180. If we take a closer look at the supplier, we notice that in the supplier dataset, they're listed in Mexico. So it's quite possible that the price is not listed in dollars, but in pesos. Let's move on to orders. Notice records 9 and 10. 9 has an unusual order ID number, which seems out of range, and record 10 seems to be missing the customer ID. Also notice how, in terms of the year, month, and day format, the dates seem to be missing the years. Let's also take a look at record 11, which seems to be extremely old, and also doesn't seem to conform to the year, month, day format either. Last, let's pull up the supplier IDs at the supplier data set. So once again, we could see that one of the IDs is of unusual length, and some of the cities are initialized. All right, now that we took a quick glance at the data, we noticed all kinds of issues with our data set that we need to consider.